design pattern to ensure that we have only one single instance of an object. And what we are going to do today is we are going to go through a code example. We are going to talk about the kind of outputs. We are also going to talk about what are the key things to look out for when you are coding your own Singleton, and also some ways through which you can avoid common problems. This material has been inspired by Dave Ritz's post on object-oriented programming patterns in SystemVerilog. He has posted it on Verification Academy as well as on EDN. So let's dig in. So first we declare a base class. Let's just call it component. Then we declare an extended class called root. This is similar to how UVM root and UVM component are. We declare the local variables. We declare the root class having a local handle called me and an access count of 0. Then we declare the new function. We declare a get function and declare a print function. Let's look at how we are going to call them, and then we'll go back to the code. We declare two handles to them, mroot and mroot copy. The mroot we are doing a get here, and mroot copy we are doing a get here, and then we are just calling the print function. Let's see at what the output looks like. The output prints out 1, 2, and 2. So this gets printed to 1, this gets printed to 2, and this gets printed to 2. Now let's look at what the code is doing. The code has a new function as a typical class would. The difference is you have a local classifier added here as a lifetime classifier. Then you also have variables of the class which you are declared within it. So we are writing the class root, and within that we are also declaring a pointer to that class itself, which the compiler will link dynamically later during the compile stage. Then we have a local static variable access count. In the get function, we are also declaring it as static. We say that, hey, if me is null, that is if me does not exist, only then new it. Otherwise, just return me, which has already been declared, which means that you can only have one and only one object of this type. Additionally, by declaring the me or the root variable me as local means that you cannot access this me from outside. You can only do it via calling a get or via calling any of the accessor functions. Also, by having the new method as local means that you cannot do here root. So this would be illegal and this would not be allowed. So this is not possible. You can only do it via the get method. Other than that, we have an access count which we are incrementing every time you access the get, and we are doing a print call. The print call is just going to print the access count value. The interesting thing about this is also from SystemVerilog perspective, if it's a static function, it can only access static variables as well as other static functions. If I were to remove the static keyword from print, it would not be able to access the print method from get. So now that we've looked at the code, we've looked at the output, let's look at the common pitfalls and how do you get around it using the same coding guidelines that we've discussed here. First is, as Dave has mentioned in his post, is that we should not declare the object as static. So when we are declaring this here, the root, we should not mention that this is a static root. because what happens is as soon as you declare it as static, you are not sure the order in which it will be initialized. We all know that it happens before time 0, though we do not know the specific order. And by removing the static keyword, we ensure that it only gets instantiated whenever we are first accessing it, which is why the get method or any other methods which we can declare later. Alright, then using the local keyword before the object handle, which we discussed here, doing this local, make sure that you cannot do root.me. So here, no one would be able to do this. You cannot do this. And copy. This would once again also be illegal. Also, the local keyword in front of the new declaration ensures that you cannot do this. So this covers the third point, and this covers the second point. And let's move this up in the order in which we are discussing. Point 2, point 3. Alright, so that ends the session on Singleton class. We'll be using these same concepts for a future video session which we are going to do on proxy classes and factories, which is more interesting, though these concepts are going to be important and will be leveraged there. So thank you.